So the team test from this chapter includes all the application problems, all the word problems, all the story problems, the things that kind of take all these different equations and apply them. So these are the things you're going to want to be studying tonight and kind of looking for. First thing, we'll put a little star here, is Newton's law of cooling. So Newton's law of cooling is definitely going to be on the test. And between you and your partner, the two of you are going to have to know the formula together. Hopefully you'll both each know it, but you're going to have to know the T minus T sub S equals quantity T naught minus T sub S times e to the negative kt power. You're just going to pretty much have to know that formula. So I'm boxing it here. So whoever your partner is tomorrow, and you get to pick, the two of you got to be able to come up with this together on your own. And you have to know that T naught is the initial temperature of the object. So initial temp. You have to know that T sub S is the surrounding temperature. So surrounding temp. And the T all by itself is just the temperature of the object. So temp of object. So make sure you review. Go back and look at your notes. Look at some of the problems we've done in class with the apple pie sitting out to cool. Some of those examples that we've seen, and be ready for Newton's law of cooling. Then the other area we're going to break into for the test is banking and radioactivity problems. So that generic formula, F of T equals Y naught e to the kt power. You really got to know the generic formula. You know that this can apply to banking problems. If it's banking, we're talking about money growing in your account. We're usually talking about a positive K value. So positive growth value. Or you could talk about radioactivity problems, so radioactivity, where we're talking about decay. So we have a negative K value. Negative K value. Either way, this formula comes into play. If it's a banking problem, you have to be super careful. It only applies when interest is being compounded, added to your bank account continuously. If you're adding your interest monthly or weekly or annually, then this formula is not going to apply. So continuously is your key word that you're going to be looking for on that one. And we're going to kind of break it down into some categories over here. So let's talk about banking for a second. A lot of times when you're doing a banking problem, we rewrite this formula as A of T as the amount of money. And we say it equals the initial I naught, the initial amount of dollars in your bank account, times e to the kt power or RT power, where R equals your interest rate. But it's the same as your K value. Your interest rate is your K value. It's kind of the same difference. Then we have a second banking formula. A of T equals the initial value times 1 plus R divided by K to the KT power. And this is called your standard banking formula. So standard banking formula. It's kind of a weird looking banking, but that's my K. So the standard banking formula is for whenever you're compounding your interest, annually, monthly, weekly, quarterly, pretty much anything that's not continuous. So the standard banking formula has no exponential, and there's a big difference between these two. Both of these formulas, you got to know. You and your partner are going to have to be able to use them and know them. So they're not going to be given to you on the test. So you got two banking formulas and the Newton's law of cooling to kind of worry about. And then you also have our last thing, which is going to be the radioactivity problems. So radioactive problems. And when we talk about radioactive problems, I'm talking about things like half-life. So you got to understand what the half-life formula is. So you should all have it memorized as the natural log of 2 divided by k. And you know that that original formula f of t equals the initial value, we call it I naught or y naught, either way, e to the negative kt power. There's a negative k value because you're decaying. So that's pretty important that you make sure you feel like you have both these formulas down as well. Alright guys, you should be done with all of these problems. Hopefully you're unpausing the video now. I'm going to roll through the answers pretty quickly here, but of course you can stop and pause if you need to. The first problem, we're looking at Newton's law of cooling. So let me show you what the answers are and kind of how I'm going to grade it. So for the team test, these are the things I'm going to be looking for. Facts, formula, being able to solve for the K, and getting the right answer. So you should, right when you start your team test, be able to write out what are the facts from this word problem. So the initial temperature is 98 degrees. The surrounding temperature is 20 degrees. Temperature when it's 38 degrees is at 5 minutes. Plug it into the formula. Here's the start of our formula. That's 1 point right there, just getting all those facts written down. And that's what I'll look for tomorrow. Then you're going to go solve for K. So to solve for K, you're going to plug in this 38 in 5 minutes. So I'm going to plug it in down here using the correct formula. And then you got to go to work. You got to be like, okay, 38 minus 20 is 18. 98 minus 20 is 78. So I have 18 equals 78 e to the negative 5k. Okay, we'll divide the 78 away. Then take the natural log of both sides. And then divide the negative 5 away. So my k value, I'll scoot this up, is natural log of 18 divided by 78, and then all divided by negative 5, which is 0.293 as a decimal. Whatever that number was, 0.293, whatever, store it in your calculator, save it, because you want to use the entire decimal later on. So store that k value. And finding k counts for a point on the test, so there's a point. Now, once you've stored it, you're going to do the last and final step here. We're actually going to answer the question. You're going to go back to your formula, plug everything back in, but now you have a k value. And I wrote it like this. I didn't write the decimal. That's k, natural log 18 divided by 78. So, since we've stored it and we're plugging it in, now we're ready to solve, and you should get time equals 7.765 minutes, which means it will take an additional 2.765 minutes to cool down. So we already knew about the first 5 minutes. So the answer is the one in the circle here. It'll take an additional 2.765 minutes. And that would be final answer. Then question number 2, let's flip this over. We're doing bank account problems. Here's what I'm looking for. List the facts, get the formula right, and get the answer right. So here's the facts. Initially, the money is $6,000. The interest rate is 4% as a decimal 0.04. Monthly means we have a k equals 12 value, and time is 7 years. So we're going to plug in to the formula all these facts and get $7,935 and about 8 cents. 0.083 if we go 3 decimal places. And then question number 3, same thing. I'm going to give you 3 points for this one, facts, formula, and answer. So here's all the facts. $3,000 initially, 5% interest, annually is a k value of 1. You're doubling it to 6,000. So you're going to set it up like this. 6,000 equals 3,000 times 1 plus 0.05 divided by 1 to the 1t power. And then you'll do all your solving. And this requires you to bring in a log. Oh yeah, I got really messy with my logs here. I should probably re-show you how to do this at the end here. But you do log divided of 2 divided by log of 1.05. And you get 14.206 years is your answer. So 14.206. So notice all these facts are counting for points. So like number 4, facts, formula, answer. 3 points for this problem if it was on the test. These are the facts. I listed them out. I labeled them. Interest rate is 3%, initially $5,000. $10,000 is what we're going to be getting. Here's my formula. I wrote down the formula. It's continuous, so I'm using the continuous formula. And now I plug in all my facts, and I solve, and I end up needing to use natural log to get rid of my e. So again, you can pause the video if you need to, but you natural log both sides, solve for time, and get 23.104 years. My answer is labeled. And then question number 5 are radioactive problems. We've got 1 point for solving for K and 1 point for the formula and 1 point for the answer. So K is 0.0112. Half-life formula is natural log of 2 divided by K. And plug it in, you get 61.8888 years. So there's our 3 points for that problem. And then the last question, question 6, here's how it's going to be graded. 1 point formula, 1 point for getting the 10% and the initial value of 1 in there correctly, and 1 point for the answer. So we've got, here's our formula, plug in 1 and 0.10, solve using natural log on both sides, and divide this away, and you get 205.587 years. So 205.587. So basically, the test is going to look like this. It might be a little longer tomorrow, not much longer though, and you're going to have to know the formulas. And what I'm really going to be looking for is, like I've been showing you in these boxes, getting the right formula written down for each problem, getting the facts written down, and then getting the right answer. I would especially note, if I go back here, sorry, most problems are going to be graded kind of based on this idea. Facts, formula, solve, answer. So you'll know how it'll be graded. So come ready tomorrow, study with your partner tonight, make sure you all have the formulas down, and I'll see you.